Hello everyone, I am Srimati V.T. Dokrat from KTHM College, Department of Mathematics. Today we discuss about SYBSc Mathematics, Paper 2 Graph Theory. Okay, in this we discuss some operations regarding to graphs. In this we discuss union of two graphs, second intersection of two graphs, third one ring sum of two graphs, next product of two graphs. To discuss about the different operations on graphs, we first see what is graph. So here graph is an unordered pair of two sets, that is V, E. In this V and E both are non-empty sets. This V is called as vertex sets and whose elements are called as vertices, and E is edge set. The elements of these edge sets E are nothing but an ordered pair of two vertices V1, V2 belongs to V. An unordered pair of two vertices V1, V2 belongs to V. Then such an ordered pair is called as graph. Such an ordered pair is called as graph. For example, we can consider here. Suppose this is our graph, means in this we are given some vertices V1, V2, V3, V4. Corresponding edges are E1, E2, E3, E4. So this is the structure of graph. Now we have to define different operations on this graph. Okay, so we first consider the different operations on two graphs only. Okay. Our first operation is union of two graphs. Union of two graphs. Suppose we are given two graphs G1 V1 E1 and G2 V2 E2. These are the two graphs. Then union of these two graphs is a graph whose vertex set is the union of vertex sets of these two graphs, that is V is V1 union V2 and edge set E is nothing but the union of edge sets of these two graphs, that is E is equal to E1 union E2. Okay. Now for examples here, suppose we are given a graph V1, V2, V3, V4, V5, E1, E2, E3, E4, E5. This is our graph G1, and suppose our another graph is like this. V5, V3, V4, V6. Okay, here the edges are like this. Here this V5, V3, that is E2, V3, V4, E3, V5, V4, E4. Now we add here some more edges. Suppose this is here, we come up to E6 edge, E7, E8, E9. Suppose there is an edge like this, E10. Okay. Now these are two different graphs, G1 and G2. And now we have to perform the operation of union on these two graphs. So here, union of these two graphs, we already see that union of these two graphs is nothing but a graph whose vertex set is the union of vertices of these two graphs and union of edges of these two graphs. So here, in our union of these two graphs, which we denoted by G1 union G2, I write first here vertex set, that is V. V is nothing but union of these two vertex sets, that is V1, V2, V3, V4, V5. Write all the vertices from first graph and then write the remaining vertices from second graph. Here V3, V4, V5, that already written. So what is remaining here? V6. Edge set is E is equal to, again write all the edges from our first graph, that is E1, E2, E3, E4, E5, E6. Okay, all these are the edges from first graph. Now we have to write the edges from second graph. Up to E6 we already written, E7, E8, E9, E10. Okay, so this is the vertex and edge set for union of these two graphs. Now, when we have to draw the union of two graphs, then what we do for our convenience, it is not necessary, but for our convenience, we draw the complicated graph from the given two graph first. Okay, we draw the complicated graph from given graph first, and then we adjust the vertices and edges from remaining graph. So in this, both the graphs are not so complicated. So here for our convenience, suppose I draw here G2 graph. Okay, I draw here first G2 graph, right, or draw this graph as it is, E2, E3, V3, E7, V4, V5, E4, E10, V6, H, E9, E8. Okay. Now I draw this G2 graph as it is, and now while drawing this union of these two graphs, now we have to adjust this G1 graph here. Okay. So see here, in G1 graph, there are V1 and V2 are not covered here. Means we have to draw that vertices. So see how we have to draw that. See here V5, V3, and here we draw that V1 and V2 like this. See here, above the V5, we write V1, above this V3, we write V2. Okay. Then join that V1, V5, this is nothing but E5, V1, V2, this is an H, E1H, V2, V3, that is E2H. Okay. And again in between V5, V6, V5, V6, there is V5, V3, there is an H, E6. But here E6 is not there. So we have to draw that edge. That is E6 is from V5 to V3. V5 to V3 there is an edge E2. But in G1 there is an edge E6. So we draw here this as a parallel edge. This is our E6. Okay. Then check whether E4 and E3 are already there. Now check whether the given graph contains all the edges from this set or not. E1, E2, E3, E4, E5, E6, E7, E8, E9, E10. Vertices V1, V2, V3, V4, E6. So this is the union of two graphs. A second operation is intersection of two graphs. Intersection of two graphs. Here, when we are given two graphs, G1, V1, E1 and G2, V2, E2. These are the two graphs. Then intersection of these two graphs is nothing but a graph whose vertex set V is here, whose vertex set V is the set of all vertices which are common to both V1 and V2. Okay, both V1 and V2, that is V1 intersection V2, and edge set E consists of those edges which are common in both, that is E1 intersection E2. Okay, so see here, suppose our graph G is like this. G1 graph is suppose V1, V2, V3, V4, E1, E2, E3, E4, E5, E6. Okay. Now suppose this is our graph G2. V4, V3, V2. Suppose we denote this by E4. This is our E6. V3, V4. This is V2. Here we take additional vertices V5 and V6. Okay. Now edges are, this is E4, E5, E6, E7, E8, E9, and suppose I take here one more, E8. Okay. Now these are the two graphs. And now we have to take the intersection of these two graphs. So intersection of these two graphs is nothing but a graph whose vertex set V is the set of those vertices which are present in both V1 and V2. So here which are the common vertices here? V2, V3, V4. Means there are only three common vertices, that is V2, V3 and V4. And now we find the common edges. So see here, common edges are E1 is not here, E2 is not there in second graph, E3 is again not there, E4 is there. So we have to write E4, E5 we can take, E6 we can take, this is common, E6, okay. Now E7, E8, E9, E10, these are not present here, okay. Now we draw graph G1 intersection G2, okay. So see here, we want only V2, V3 and V4. See here, that common part from both the graphs. So this triangle, so see here, V4, V2, V3, E4 is there, E5 is there, E6 is there. Okay. Here we observe that E3 is a loop in first graph, E4 is a loop in second graph. But this is E3H, this is E4H. Though we observe that this is the loop and we observe that this looks as a common in both the graphs, but we cannot take this because both loops are representing the different edges. These loops are different, that's why we cannot include that here. Okay, means you have to take care of this. Though loops are looking here or appear here. So here you observe that names are different. These are the different loops. So we cannot draw that loop here. Okay. So this is the intersection of two graphs. Intersection of two graphs means this is the common graph from both the graphs. Now we consider third operation on graphs, that is ring sum of two graphs. Suppose we are given two graphs G1, V1, E1 and G2 and G2, V2, E2. Then ring sum of these two graphs is denoted by G1 ring sum G2. And this is again a graph whose vertex set V is nothing but the union of vertex sets of V1 and V2. That is V is equal to V1 union V2 and edge set E consists of those edges which are either in E1 or in E2 but not in both. But not in both means what? We don't consider here common edges. Means edge set E consists of E1 union E2 minus E1 intersection E2. Okay. So this is the edge set for ring sum of two graphs. Means ring sum of two graphs is a graph whose vertex set is the union of vertices of both the graphs and edge set consists of those edges which are either in E1 or in E2 but not in both. Now for example, here suppose our graph is G1 is like this. V1, V2, V3, V4, E5, E1, E2, E3, E4, E5, E6, E7. Okay. Now we consider here another graph G2. The graph is like this. V1, V2. Here I'll take here E7. Suppose this is our E8. We add here vertices like this. V5. We come up to V5. So here V6. V7. Okay. Now we add here edges E8, E9, E10, E11. We take some common edges to both this graph. Here E7 is only one edge which is common. So suppose I take here V1. Okay. Suppose I write here E3, V3 again. Okay. So this is our V2 to V3 is E2. Okay. Okay, we can join this by again E12. Okay. So here which edges are common here? E2 and E7. Okay. Now see what is the vertex set of ring sum of these two graphs. Now ring sum of these two graphs I draw here. Okay, we can draw here. G1 ring sum G2. G1 ring sum G2 whose vertex set is nothing but the vertices from both the graphs. Okay, so we have to draw all the vertices. So this is V1, this is V2, V5, V3, V4. Now from second graph I write vertices from first graph first and then I adjust vertices from second graph. Okay. Now from second graph which vertices we needed here? V6 and V7. So suppose I write that here V6 and V7. Okay. Now this is the vertex set for ring sum G1 and G2. Now, edge set of this ring sum is nothing but the edges which are either in E1 means either in G1 or in G2 but not in both. Means we have to remove here common edges. Okay, so delete common edges and draw all the remaining edges. So see here E1 occurs only in first graph, so we draw that. E2 here occurs in first graph as well as in second graph, so don't draw that. E3 occurs in only first graph, so draw that edge. V3 to V4, this is E3. Okay, now next E4 occur in only first graph, so draw that. V4 V5. Okay, next one E5 V1 to V5 does not occur in second graph, so draw that edge. E5. Next one E6 occur in only first graph, so draw that. V5 to V3. E6. Next E7 occurs in both the graph, so delete that. Don't draw that common edge. Okay, after that I think edges from first graph are finished. Now we consider in second graph E8 from V1 to V2. E1 is already there. See here, this is E1 edge, this is E8. Though the end vertices are same, but the names are different, means these are the different edges. So this is E1 and this is E2. Okay, E9 is from V2 to V7. So we draw like this. Okay, this is our E9. After that E10 from V6 to V7. E10. E11 is from V1 to V6. So this is E11. Okay. E12 is from V3 to V7. This is E12. Okay. Check whether all the edges are covered or not here. See here E1, E2 is common in both the graphs, so we remove that. E3 is there, E4, E5, E6, E7 is common, so we remove that. E8 is there, E9 is remaining. Okay, E9 is here. E10, E11, E12. Means all the edges are covered here, all the vertices are covered. We don't consider here the common edges, so this is the ring sum of two graphs. Now our next operation is, that is fourth one, product of two graphs. Product of two graphs. Suppose we are given two graphs, G1, V1, E1 and G2, V2, E2. These are the two graphs. Then product of their graph is denoted by G1 cross G2 and is again a graph whose vertex set V is nothing but the Cartesian product of two vertex sets V1 and V2. Okay, means here the vertices of this product of two graphs is nothing but the set of ordered pairs. Okay, and edge set means here vertices of the G1 and G2 is of this type U1, U2, V1, V2. Okay, these are the ordered pair. Means vertices of this product of two graphs is nothing but the ordered pairs. And now how the edges are formed here, and the edges are nothing but, see here, there is an edge between this vertex U1, U2 and V1, V2 if U1 is equal to V1 and U2 and V2 are adjacent in second graph G2. And these are adjacent if U2 is equal to V2 and U1 and V1 are adjacent in first graph G1. See here, what I say, the product of two graphs G1 cross G2 is a graph whose vertex set V is the Cartesian product of V1 and V2, whose elements are the ordered pairs like this: U1, U2, V1, V2 belongs to V1 cross V2, and the graph contains edges such that means these two vertices. This is one vertex, this is other vertex. So these vertices are adjacent if first vertex is same and second vertices are adjacent in second graph, or second vertices are same and first vertices are adjacent in first graph, then and only then these vertices are adjacent. Okay, now see how this graph is. Suppose we are given a graph G1 like this. We consider the simple graph. See here, suppose we have, this is our G1 graph, A, B, C. Okay, these are the three vertices in graph G1. Okay, there is no need to naming the edges here. Suppose our graph G2 is like this, P, Q, R. Okay, P, Q, R. Now here G1, this is our G2. Okay, so now we want here product graph G1 cross G2. So for this we first write the vertex set, and we know that for vertex set, for product of two graphs, vertex set V is nothing but the Cartesian product of two vertex sets. Okay, V1 cross V2. See here, what are the elements of V1 here? A, B, C cross V2, P, Q, R. Okay, now we form here Cartesian product of these two sets. So how to write that Cartesian product? Cartesian product means what? It is the set of ordered pairs in which first element is from first set while second element is from second set. Means what? See here, first element from first set, second element from second set. We repeat for this, we keep first element fixed, consider the remaining element in second set, that is AQ, AR. Again take the second element in first set, that is B, BP, second element from second set, BQ, BR, next one, CP, first element from first set, second element from second set, CP, CQ, CR. Okay, now this is the vertex set for product of two graphs. Okay, that is V. Means we have to draw these 9 here, 3 into 3 means total there are 9 vertices. So now we have to draw 9 vertices for product of two graphs. Okay, now here we draw that first, second, third. Okay, we naming like this: AP, serially we give the names AP, AR, here, BP, BQ, BR, CP, CQ, CR. Okay, now here this is the vertex set and these are the ordered pair. Here these are the ordered pair of two vertex from G1 and G2. Okay, now we have to draw the edges. Now here, we already see in the definition that when we consider the edges or when two vertices are adjacent. When two vertices are adjacent, if first element are fixed, means fixed, and the second vertices are adjacent in second graph, or second element are fixed and first elements are adjacent in first graph. So see here, AB, AQ, here A is fixed. So check whether this P and Q are adjacent in G2 or not. If they are adjacent in G2, then join that two vertices. Okay, see here, A is fixed, P and Q are adjacent in G2. So we join that two vertices. Okay. Now again see here, similarly we go below here. B is fixed, P and Q are adjacent, join that. C is fixed, P and Q are adjacent in G2, join that. Okay. Now next, for this AQAR, A is fixed, check whether Q and R are adjacent in G2 or not. Here they are adjacent in G2, so join that. Similarly, B is fixed, Q and R are adjacent in G2, join that. C is fixed, Q and R are adjacent in G2, join that. Okay. Now here P and R. Okay, we join this. Now we check for this AP and AR. But P and R are not adjacent here. P and R are not adjacent here, so we cannot join this. Okay. Now here we consider like this. Okay. Now here adjacency in G2 is considered finished. So we have to consider now adjacency in first graph. So again for this we consider A, B, C. These are varying like this, no? So see here, P is fixed. Check whether A and B are adjacent in G1 or not. A and B are adjacent in G1. P is fixed, so join that. Again, Q is fixed. A and B are adjacent, join that. R is fixed. A and B are adjacent in G1, join that. Okay. Now again here, P is fixed. Check whether B and C are adjacent in G1 or not. In G1 they are adjacent. Join that graph. Okay, I draw like this. Q is fixed. Join B and C. R is fixed. B and C are adjacent in G1. Join that. Okay. Now again, P is fixed. Check whether A and C are adjacent here or not. A and C are not adjacent, so we cannot join that. Okay. So in this means adjacency in both G1 and G2 is considered by keeping first or second element fixed. So in this way we can draw the product graph. For example, again here, if I add here AC, okay, if I add here AC, then what means there is an edge between A and C. Then what happened? Here see AP and AC, P is fixed, A and C are adjacent in G1, so we can join this. Okay. Again here Q is fixed, A and C are adjacent, we can join this. R is fixed, A and C are adjacent, we can join this. Okay. Means here we can add here one edge, and due to addition of one edge, there is an addition of 3 edges in this graph. Okay. So it is means when we have to consider the product of graph, don't add edges arbitrarily in any graph, because it makes very big effect in these edges. Okay. So be careful about that. In this lecture, we learn what is graph, what are the different operations on graphs, that is union, intersection, ring sum and product of two graphs. Now, in our next lecture, we discuss something about fusion of vertices, fusion of vertices. Second, removal of vertices. Removal of vertices and edges. Next one, decomposition of a graph. Thank you.